Hello GGS 300 and welcome back to the 6th lecture for quantitative methods for spatial science. Today we're focusing very quickly on sampling. So obviously there's no assignment this week and this is only going to be a very short lecture. It's just a bit of an overview to give you some understanding of sampling before we move on to later parts of the course. Obviously your focus is going to be on taking the ungraded tests that I've put up onto Blackboard. And these are basically going to give you an understanding of what you need to do before you take the graded midterm exam, which should be the last assessment that's currently up within the assessment area on Blackboard. Okay, so reach out to me if you've got any further queries or questions, and hopefully you'll all be performing to the very best of your ability over the next week on that graded exam. Okay. So let's focus on data sampling very quickly, and it's not going to take very long today. What is sampling and why do we do it? Well, obviously I'm moving now from the kind of descriptive part of the actual course, and we're going to be getting into inferential statistics. So this is more formalized hypothesis testing, where we basically take samples from a population and we try to derive parameters and other types of important statistical information about a total population that maybe we haven't carried out a full census on. Okay, and it's going to differ quite substantially from the more descriptive statistics that we carried out in the previous case. Hopefully by now you all understand that a sample is going to be a subset of entities from a total population, and the population also is kind of defined as the total number of entities that exist within some sort of area that we've delineated ourselves based on some sort of boundary or some sort of social group that we're interested in, or just society overall. Okay. So we're moving from the left-hand part of this graphic, which focuses on descriptive statistics, over here into inferential statistics, testing hypotheses formally, evaluating those hypotheses, and then, sometimes also refining and developing that model and that theory a bit further, but hopefully more importantly, actually kind of gaining impact from that work. So making sure that we try to make the world a better place. What's the aim of sampling? Well, this is essentially for us to actually be able to make an inference about an overall population. Okay, so we need to be able to represent that population well using sampling techniques, and quality is going to be really important. So the degree of accuracy that we have within the instruments that we actually produce. Okay, I'm going to talk more about how sampling is effective in this way very shortly. Why do we need to sample? Well, really, it's through necessity. Okay, so we might have very large populations. Maybe the population isn't accessible. Maybe it's just expensive to survey a full population, and therefore we need to find more efficient, more cost-effective approaches to derive population-level parameters so that we can understand information at a larger level. So it can be highly accurate if someone's carried out who's highly trained and they've been rigorous. They've designed a rigorous and robust sampling method in order to obtain these parameters of interest, and they can be highly repeatable. Okay, so often we might do a full census every 10 years, and then for those interim periods what we might do is we might use samples of data combined with some forecasting capabilities in order for us to actually make estimates of what the population parameters are overall. So the goal is basically to develop a sample which is truly representative of a set of values from that overall population. So what we're trying to do here is get key characteristics without introducing an unacceptable level of bias into those estimates. So a sample design is required. So this is basically the procedure for how we actually select individuals from a population, okay? And to actually achieve that kind of accuracy that we would like within our sampling instrument, we need to have both this design that I'm talking about, so a sampling framework, and also an appropriate number of samples. Okay, so you can't just pick the design and make it effective. You have to then get a representative number of samples within that sampling framework in order to obtain something that's likely to be highly accurate. So there's going to be a big trade-off here between accuracy, cost, and sample size. So if you look in the book, you'll have this graph which has an x-axis where you've got the sample size, so small sample down here and large sample up here. And then on the y-axis, you have the amount of imprecision going from low to high, and you have the amount of effort on the second y-axis going from low to high. So if we have a small sample, then we're going to have high levels of imprecision, but we are actually going to have a very low amount of effort involved in collecting that. So it's quite cheap, it's quite time effective. And that kind of contrasts with a large sample, which obviously is going to be much more precise. So if you look at A here, the A line is low here, so the imprecision is low, which means it's more precise with a larger sample. And if you look at the B line, it's high, which means we've got a high degree of effort. Okay, so in order for us to get that kind of imprecision, so that precision level that we want, we're going to need to exert an appropriate amount of effort in order to get it. So there's a trade-off, unfortunately, within this. And you'll remember from the probability lecture, I gave an example of how we might carry out experiments using a coin where we flip heads or tails. We might just flip it 10 times and we might get 8 heads, and it might produce a relative frequency of 0.8, so an 80% probability of producing heads, which we know from our existing knowledge, our a priori knowledge, that this is incorrect. We would expect a 50-50 chance of getting a heads or a tails. But obviously, if we exerted a larger degree of effort, we flip the coin 20 times, so 20,000 times, then we could end up with something that's much more reliable. Okay, so it's more effort, but it's got a lower degree of imprecision, it's much more precise. So we end up with something that's basically 50% chance for a heads, and therefore the reciprocal would be 50% chance for a tails. So this sampling design, there's lots of different ways that we can do that. So we can just use simple random sampling, we can systematically sample, we can create we can stratify a sample, so we have stratified groups, we could cluster, or we could use a hybrid approach. So within this procedure that we're going to carry out here, this is just an example. There's a set of different steps for us to obtain the sample. So here we have the need as the first step to actually define the target population. So if I gave you my kind of standard example of us needing to go out and sample something, it's going to be looking at the house prices in the city of Fairfax, and therefore the target population is going to be the boundary of the city that we're going to lay out, and then all of the properties within it will be the entities that we could sample. Okay, so that's the target population that we can geographically identify. We can then define the sample population within the sampling frame. So the sampling frame will be the structure that contains all the elements to be sampled. So the question is, well, how do we actually obtain those property prices? Do we just randomly select properties that we want to go out and sample, or do we break the number of samples that we get down into neighborhoods, or do we select in neighborhood areas and then sample within them randomly? There's all these different approaches, but you need to pick some of these based on kind of the question that you have and what you want to achieve. So you kind of need to be cognizant of the advantages and the disadvantages of these different sampling frame approaches. We can then use a design which can be based either on a non-probability based approach or a probability based approach, and I'll explain more about that in the next slide or so. And then we need to actually prepare the research instrument. Okay, so we need to basically decide how we're going to collect that information, whether it's by observation, field measurements, surveys, interviews, etc. And then importantly, we need to pre-test and potentially revise the sampling plan, because the likelihood is that something just might not work in the field once you actually deploy it, and then therefore you need to know that early on in the experiment, so that you don't go out and carry out all of the sampling that you need and then realize that your results are junk, basically. Okay, so that's what you do before you collect the actual samples. What is a non-probability sampling design? Well, this could be more of a kind of qualitative approach to actually sampling. Okay, and there's two different types. Maybe it could focus on convenience sampling, so you just go up to random people in the street and you just ask them their political views or their feelings on a particular policy, maybe, and that would be an example of opportunity sampling. And that contrasts with actual targeted sampling, which is something which I've used before and which I would recommend as a better option out of these two. So you could use targeted sampling, focusing on just experts, subject matter experts that you want to interview because they already have a lot of existing knowledge. Or you could do other types of approaches such as heterogeneity sampling or snowball sampling. Okay. Now on the probability-based sampling methods, which I'd much prefer you to use, because this is much more akin to the type of statistical methods which I think you should be learning and applying within this field. Really, you've got these different approaches, so you could focus just on types of spatial point sampling here, or you could use composite or hybrid sampling strategies. So in the more basic end, what you just have is random sampling of points, or you could systematically sample different points, or you could take different approaches based on how you could stratify the underlying data layers, okay? Over here, what we've got is a stratified systematic approach here, more systematic stratification, or we could approach two-stage sampling approaches, which may focus on clustering. So maybe you divide into quadrats first, and then you carry out some sort of systematic evaluation within each of these clusters. Or you do something even more funky over here, which is disproportional stratified cluster analysis. Okay, look, let me give you a bit more of an overview of each of these methods now. It's only going to take me a few more minutes, and then that's going to round off the lecture for today. So simple random sampling is dead easy. Essentially, you have a uniform probability, so that just means an even probability for selecting each of the different points within that whole sample space. Okay, so let's just say that this axis here is between 1 and 10, and this axis here is between 1 and 10 as well. You could just say in R or Python, generate me a set of numbers. Let's just say we want to sample 100 points between 1 and 10, and obviously that's going to give you a set of, let's say, float, so numbers with decimal points, and then they're going to give you a vector of these 100 points, and you could use one as the x-axis and one as the y-axis, and when you put them together, each row would basically be a coordinate within this sampling space that you've basically been able to obtain. So it's very fast, cheap, and simple, but you may end up overlooking some of the underlying patterns that exist within what you are sampling. Okay, so you may avoid important locations, or you may overlook important trends that you might need to be cognizant of. Systematic sampling, so this is basically where you have a regular sampling interval, so you create a grid out of this entire quadrat area, and then for each of the individual smaller tiles, each of those smaller quadrats, you could basically get the centroid point, and that would produce this type of point grid that we've got here. So it's easy to implement, but unfortunately it may also miss important individuals. Okay, so you need to check for randomness in the arrangement of the individuals that you want to target. Stratified sampling, so this is where we have a target population stratified into different subgroups. So the individuals or the subgroups are very much alike in terms of the variables which we're estimating, and then you can go into each of those subgroups and draw a certain number of types. Okay, so you could do this for demographic age ranges, so people between the age of 20 and 30 are going to be more alike than people between the age of 70 and 80, and therefore you specifically want to sample a number of people within each of those age groups, because they're probably going to have different views, different outlooks on life, different habits, different behavioral patterns, things like this. Okay, so I've given you some examples here from the book, which are just spatial. So maybe you have different landscape types and you want to take points from within those different types of landscapes. So it may mean that you've got a more representative sample, less biased, but it could introduce additional complexity to your sampling approach. In cluster sampling here, this is where we have a target population divided into individual subgroups. Okay, and then we could select a number of clusters that we're interested in. So maybe we've got these 4 clusters here, these 4 quadrats. Maybe we just randomly selected them. And then we could actually randomly sample in each one of those cluster quadrats and basically use a random sample within them. Okay, so we're basically using a two-stage strategy, which can ideally decrease the cost of basically sampling this whole area. Okay, so you can use a representative number of the actual quadrats, and then you can do lots of individual sampling within them. So you just need to be aware whether the clusters are actually biased in some way, the way in which you selected them. You need to try to just be aware of any sort of systematic problems that you might introduce into your sample. Hybrid sampling, so this is where we could combine different sampling designs. So we could take a stratified sample. So let's assume that we break them into this grid, sample area into this grid here. So we know that then if we randomly sample within each one of these places in the grid, we're going to have a reasonably even spread of sampling points across this whole area. Okay, so you still get a nice random point that you're interested in, because you know that that's going to be less biased, but then you're going to make sure you get an even spread of them, unlike just the simple random sample which we had before, where you could end up missing certain places, or you could end up with clusters of random points. Okay, so there's a certain number of pros, you get an even distribution, but then the cons are that you need to actually still make some exogenous decisions about the size of the grid squares, okay, to ensure that you've actually got a fairly representative and high quality sample of the underlying phenomenon which you're trying to obtain. Look, this has been very short. I didn't want it to be long this week because you've got a lot of other things to worry about. So make sure that you do the ungraded tests that I've set you, and that will really prepare you for the actual exam, which then you're able to take, okay? So reach out to me if you've got any further questions. Obviously, it's only the exam that's going to be graded, so the tests beforehand are just kind of prep in order to make sure you know what to revise for the actual exam. And don't hesitate to reach out. Okay, so thank you very much, ladies and gentlemen. And I guess what's left for me is just to wish you good luck for the midterm. And I hope you will perform to your best. And I'll look forward to seeing you all soon. So thank you very much for your time. Take care. Bye-bye.